Privit, Drusi, ja Arto, sa Finlandigi. I hope that went more or less correct. I'm afraid that's about the only Ukrainian I know, so you are all having to suffer English tonight because of moi. So yeah, I'm Arto, and I'm based mostly in Berlin and Bratislava. It's my second time in Lviv. January was the first one. I just looked on Meetup for meetups that were happening while I was here, and what do you know, Pivorak 19, I think, was happening then. And then Anna roped me into giving a talk, so why not? Can do. So I started doing Ruby in 2004, so it's been a while. I think that was around the first time, that was the time when the first Rails releases were coming out, the pre-releases. And of course Rails was the reason for doing Ruby. Now I haven't done much Ruby in the last couple of years because I switched to Elixir, and I imagine that this is a common theme. Many of you probably have been curious about Elixir already for some time, and maybe some of you do both Ruby and Elixir, and maybe some of you have switched. There seems to be a bit of a en masse movement going on from Ruby to Elixir, and in particular, of course, from Rails to Phoenix. And with that, many people think that Phoenix is the most important thing about Elixir, and of course, by the numbers, I imagine most people who do Elixir are doing Phoenix. That makes sense, especially for people who are coming from Rails and Ruby. But I'm not here to tell you about Phoenix. I do use Phoenix. It's great for customer projects. But really good web frameworks are commodity today. After Rails revolutionized that whole field more than a decade ago, there's plenty of web frameworks around, and Phoenix is great, but I'm here to talk about what I think is the killer app of Elixir. And how many here have heard about Nerves? Okay. So this is the great thing about Nerves, that it's so early now, still in Nerves. It's only been around for a few years. Probably everybody who has heard about Elixir knows about Phoenix, but not so many yet about Nerves. And yet I think Nerves is actually exactly what Rails was to web development, Nerves is to embedded development. And this is why I'm excited about Nerves. Currently, by the numbers, you can see that I put them down there at the bottom. Phoenix is quite large compared to the Nerves community, but it's only a 12-fold difference. That's not actually that much. And I think in the long run, if you think about a decade or two further, similar kind of situation where we are right now with Rails, what Elixir will be remembered for, and what it will influence going forward, will actually be Nerves, the same way as Ruby is, for all practical purposes, forever tied to Rails in everybody's minds. So, what is Nerves? Nerves is a little hard to define because it's an umbrella project that has a lot of components. But basically, Nerves is taking embedded development to a new level. It's opening a new field. Those of you who have done embedded development in the past, you probably did it in C, C++, or if you're working with a Raspberry, perhaps you did some Python scripting. It's very easy on the Raspberry Pi. But with the combination of Elixir as the development language and Erlang OTP as the runtime platform, we have actually something really unique, and we have something fantastic. And my talk today will be in two parts. I will introduce Nerves a little bit, and then I'll tell you about my motivation, my specific open source project, why I'm so interested in it. This will all be fairly high level. Think of it more as motivation to maybe look into these technologies, learn about them rather than any sort of tutorial. It won't be a tutorial. So with Nerves, you can program in your favorite language, which is very similar to Ruby, so Elixir. Hardware devices, embedded hardware, not just Raspberry Pis, really any kind of hardware. This is a difference from previously when you had to do it in low-level languages. So this is a very simple overview of what would be involved if you were using Nerves on your project. So Nerves basically gives you a way of creating firmware for a hardware device. So this would be, let's say that you are doing development on a Raspberry Pi. This would be the firmware image that you're going to burn onto an SD card, and then you're going to boot your Raspberry Pi from it. So normally if you do Raspberry Pi development, it's going to be something like a Debian Linux image. It's going to be, at least half a gig, probably a lot larger. You boot into the Debian image, you SSH into it, and you start developing, you start installing packages and so on. But this means that you have a one-off system, which is really nasty. I think we all these days don't really want these one-off systems. We want to have a big button we can press to build a system from a recipe, whether it's a deliverable on a web project or whether it's something like firmware. And so Nerves is exactly that. You write your application in Elixir, and it can also have components in C, C++. You can include actually any components in any language you want. But Elixir is where it's at, and you have essentially a make file. This is all, of course, done with Mix, same as anything else with Elixir. A make file where you define what your firmware image, which is the final output, is going to look like. And Nerves is then the tooling and the libraries that allows you to take the Linux kernel. So this is based on the Buildroot project, which I imagine a lot of you who do embedded development will already be familiar with. It embeds the Linux kernel without a user land. It doesn't have a user land. With the OTP platform. So that's all the baseline Erlang runtime system files and then all the Beam files, both for your application and the base libraries. And then indeed your Nerves application. And out comes this firmware image, which is way smaller than anything you would do if you started out customizing a Raspbian or Debian or Ubuntu. So currently it's about 18 megs is what you can get as output if you have a reasonably sized application. This boots up real quick. Did I have? Yes, indeed. There's, it's a couple of seconds to boot up on something like a Raspberry Pi, or indeed any kind of modern embedded platform. So that means that you might think that there's a lot of overhead to be using a high-level language. You might think that it wouldn't be the best idea in the world to be using a bytecode machine for your embedded project. But it turns out it's actually a rather good fit. One reason is that Erlang as a runtime is really lean. And of course, there are good reasons for that. Namely, if you consider why you might choose a high-level language, almost any other high-level language would be perhaps a bad fit. I mean, people do some embedded in Java, of course, but there's a lot of tailoring of those runtimes. But as it happens, Erlang's roots, as you all no doubt know, are in the telecoms industry. It runs switches. The famous statistic that when you place a phone call, you have a 50% chance of going through an Ericsson switch. And it powers a lot of the telecommunications today as well, ever since the 90s. So Erlang is actually really lean and mean. The base requirements for memory are almost nothing, as I mentioned, about 8 megs for the runtime. A reasonable application is going to run in less than 32 megs. And on something like a Raspberry Pi, you have a 1 gigabyte of memory. So you have actually vastly oversized resources for what something like an Elixir application is going to need. At least typically, of course, you can use that memory any way you like. You could cache things and make a RAM disk, whatever you like, but you don't really need all of that. And the second thing is that Erlang has, the Beam virtual machine has a fantastic garbage collector. Given the shared nothing architecture, each process has its own heap, and as you know, processes are very, very lightweight. You can have 1 million processes in your operating system process, and that means that there's no huge heap to garbage collect. You don't have these massive garbage collection pauses like you have, for instance, with certain kinds of Java applications. And that means that you have basically soft real-time properties. And then if you combine this with some lower level code where you need hard real-time perhaps, to the extent that your Linux kernel allows that, you have a very nice combination. You can have all of your control logic in a functional, immutable, high-level language, and then you can drop down to C, C++ if you really need to. For, let's say, in my case, as I'll come to in a bit, computer vision. It would be silly to do computer vision, so that would be OpenCV and the like. It would be silly to do that in a high-level language like Elixir. We'd be wasting a lot of cycles. But for control logic, it makes total sense. The other thing that is a boon of Erlang and Elixir due to its history is that, of course, it was meant for implementing line protocols. I don't know all the crazy protocols they have in the telecoms world, but I'm sure there's a few million lines of code at Ericsson to handle them. And that's the reason we have this great bitstring pattern matching in Erlang and hence Elixir. And that means that programming embedded devices that have a network first kind of principle is very natural in Elixir, and makes a lot of sense to do this. And of course, every device you sell these days, Internet of Things, is going to be networked, whether it should or not. It's arguable whether your toaster really needs a Wi-Fi connection, but it's going to have one. So the other thing is that, of course, the real world is concurrent, asynchronous, unpredictable, full of bugs. And the actor model turns out to be a really good way to handle all that. And then, of course, related to that, things always go wrong. And given that, Erlang's philosophy of just let it crash is exactly the way to proceed. You have to expect failure, and you have to program for it. So given all that, these are some of the currently popular platforms that you might run Nerves on, and a number of you raised your hands about the Raspberry Pi. So that, of course, in case somebody hasn't heard of it, this has sold more than 10 million units by now. It's probably the most popular personal computer ever sold. And so these are called single board computers. These are basically equivalent to PCs as of, call it 5+ years ago, maybe closer to a decade. So they have everything that you need other than the mouse, keyboard, display, and they got ports for that. You can, even if you weren't interested in embedded development, you just wanted to make a cheap computer for yourself, you can build one very cheaply out of these components. You just add an SD card running Linux, and you add keyboard, mouse, monitor, and you have a computer. So you can build those very cheaply. The Raspberry is without question the most popular high-level embedded platform right now. But there's another one I want to bring to your attention if you're interested in this stuff, which is the BeagleBone. And currently the version BeagleBone Green is the newest one. There's also the older BeagleBone Black. And these are two platforms that they have about a similar price. So about $35 for the Raspberry in units of one, and a little more for the BeagleBone because the Beagle doesn't have the volumes that Raspberry does. The Beagle is underpowered compared to the Raspberry, but it has this huge benefit that it's all open source hardware. And despite all the positive press about the Raspberry isn't a very open platform. It's been difficult to get, for instance, Linux support for a lot of the SoC, the system on a chip components from Broadcom that they use. So it's a cheap one. Raspberry is cheap, but it's not particularly open. And the Beagle is a much better platform for hacking on in a way where you have a path to production. So if you actually wanted to make a device that you would sell to somebody or even release as an open source design so people can make it themselves, the Beagle is a much better platform. But it's not as powerful. Now, how you would actually do this is you can download all the schematics for the BeagleBone, and then you can customize it, assuming you have the electrical engineering skills, and then you can send it off to China and have 100 of them made for not much. Or maybe closer to home, I don't know. So the Beagle is what I would recommend to hack on, and another aspect of it that I'll come to in a bit is this Grove connectors. So this is basically Legos for hardware. I love the Grove system. So this is from a Chinese company called Seed Studio. Many of you may already be familiar with Seed Studio. They make a lot of products, and the BeagleBone is also manufactured by them, I believe. So they came up a few years ago with this sort of standardized connector for just hooking things up without having to solder anything. And this is of course fantastic, because if you're not really coming from a electronics background, then the last thing you want to be doing is peering through a magnifying glass with a hot iron there and something a little bit toxic that's melting in front of your nose. It's not a lot of fun, and it's a skill that takes some time to develop. So with things like the Grove system, you can prototype easily. You can the Grove is basically a very simple concept. It's a cable with 4 pins, and all of these various modules here have this connector, as you can see, and that means that you can just get these cables and you can just boom, 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 wire everything up to your BeagleBone. So the BeagleBone has an extension cape, as it's called, that you can attach to it, and you will have 20 of these ports, and then you can just go wild. So this is a really fantastic way to get started with electronics or with embedded development. And obviously, you wouldn't go to production with this kind of set of cables. You would want to integrate everything that you're doing onto the same circuit board and then produce that in volume. But for prototyping, it doesn't really get better than this. And I'll show you. Whoops, those can't really be. Can you see those examples actually? No. Okay. Is there anything we can do about that? Okay, slightly better. Well, I won't show many code examples in any case. This is mostly to show that it's very, very simple to do hardware development these days, now that we have things like indeed nerves and good libraries. So here on the left side we have the classical hello world of embedded development. We are making a LED blink. So this would be the LED module there on the, let's see, that one there. And it's a single line. You don't need to worry anything about how everything is happening under the hood. And that's the case now when we are adding in the Nerves project, we are adding support for all of these Grove modules. It means that you just have this Elixir module for each one of these hardware modules, and then you can do things like read the current button state, or let's say read the current temperature, read an analog voltage, control a relay, all the other things that you have the options here to do. There's even an alcohol sensor, if I don't know if you noticed, but in case you want to prototype in your car. And a few more examples here. So we have a buzzer, which makes a really nasty sound, wake you up. And then we have an OLED display where you can do a more classical hello world. So it's really not difficult at all to do hardware development anymore. It's all now nicely abstracted. And this also means that what I've seen, what the people in the NERVS project have seen, are that a lot of people who have no background in embedded development have gotten excited about especially the Raspberry Pi, and are getting into hardware, and it's never been friendlier than it's now. So a lot of people who might be consider themselves web developers are certainly playing around, usually in their copious free time, with technologies like this. And I suggest to you that if you're doing that, or if you're interested in that, yeah, you can do the usual Raspbian, Python, C, whatnot, but also have a look at NERVS. So NERVS is not just being used in hobby projects. As I mentioned, NERVS is a couple of years old by now, and that means that there are actually commercial devices shipping that run NERVS. So think about this. We have NERVS hasn't even reached a particularly stable state as yet, but there have been commercial devices powered by it for already a couple of years, because it is a rather fantastic solution. So this was the first one, I believe. There's a couple of companies shipping devices running NERVS. This is the best known one, called Rosepoint Navigation Systems, and they make a commercial radar systems for maritime. And that box there runs Erlang and Elixir using NERVS. Then, of course, there's really no end to what you might do with something like NERVS. So right now, nobody's saying, but I assume that these current vendors, manufacturers who are shipping commercial devices with NERVS, they're probably not shipping more than thousands of units. But I think that there's so much potential in NERVS that within a few years, I predict that there's going to be millions of units shipping, millions of devices that are actually powered by a little firmware image created using Elixir and NERVS. It could be anything from smartwatches to what I'm interested in, which is drones. Everything in between. That's a wide range. Now, even you might think, if you know about embedded development, you might think that something like a smartwatch would be impractical due to the power requirements and hence the battery design, battery constraints. But that's not necessarily the case, because the line between microcontrollers and proper CPUs is, you could draw that at the memory management unit. Some of them, if you have an MMU, you can run Linux. And most even lower-end ARMs these days that are low power and so on, they have an MMU, which means that potentially you could run Linux and Elixir on it. To be determined. So with that, just a very quick example slide to show you that if you have a Mac, this is how you install the whole NERVS stack. So this is installing Elixir and NERVS from scratch. It's only assuming you have a Mac and a homebrew. If you don't have a Mac, if you have Linux, it's even easier, and the installation instructions are here. So you can do this in about 10 minutes or so. You can have, on a good connection, you can have NERVS installed, and then you can run the Hello World examples. So this here creates a new project that you can then compile with Mix to get a firmware image out. You burn that to your SD card, and you boot it up on your Raspberry, and you have a blinking LED. So let's say in a couple of hours, even if you know nothing about embedded development, if you have a Raspberry Pi, you have a, let's call it a spare LED. The Raspberry Pi actually has an embedded LED, so you don't even need that. And you have an SD card and a laptop to get this set up with. You can in a couple of hours go from nothing to having embedded Hello World going. So it's a nice weekend project. And hey, the weekend is coming up. Pick up a Raspberry Pi somewhere. And that's about the end of what I'm going to say about NERVS specifically. I'll talk about my project and why I'm particularly using NERVS. But NERVS has a very friendly community. Currently, about 1,000 people I mentioned earlier. If you're on the Elixir Slack or if you join it, go to the NERVS channel, and it's all happening there. and the website for NERVS is predictable enough, and they have good tutorials. Also, a lot of presentation videos. So anything you want to know about NERVS, including more tutorial kind of material, you can find it there in video form as well. So I'm going to talk with my remaining time about my specific project, which is called ConReality. It's short for Consensus Reality. And this is a fairly early stage project, so it's more maybe of general interest than again any sort of tutorial or even recruitment drive, although I'll try for that too. So ConReality is an attempt to do something a little bit ambitious, which is with this proliferation of drones that we have these days. So here's one kindly lent to us by a member today, which we will fly after the talks outside, and maybe take a group photo of everyone. It has a good camera. These kind of drones can be purchased for a couple $100 these days. This one is probably a little bit more, nice mid-range. What I'm working on with some fellow colleagues on the project is bringing war games out from behind the screen out into the real world. And the reason for this is that I have 5 younger brothers, and I've seen each and every one of them get stuck behind the screen in the teenage years, and well, thankfully not in my family, but in some cases it goes on rather longer than the teenage years. Sort of a failure to launch into the real world when you have all this addictive entertainment right at your fingertips. And really it comes down to real life can be kind of boring. So I want to make it a little bit more interesting. And this is of course not a new observation. A number of authors have over the past decade or so observed that we have this actually societal level problem where people are isolating themselves from the real world, call it gaming addiction or call it just escapism, whatnot. People by the hundreds of millions are fleeing real life. And another few relevant quotes. It's not something that's in any of our power to solve, but it's what got me interested in seeing if we could make reality a little bit more interesting. And we have this other very interesting trend right now that, as you probably all have heard, this year is basically now finally the year of virtual reality and augmented reality. So it's been 20 years since this classic movie. It's a little bit cheesy, actually, if you watch it these days. But Johnny Mnemonic with good old Keanu Reeves hacking into cyberspace. And that was an early depiction of virtual reality as it was supposed to happen in the 90s. Never did. It's kind of happening this year with Oculus and so on. But of course, as you can imagine, that just makes the problem worse. That we already have immersive games. What's going to happen when they are virtual reality? We might have still more people escaping the real world. Now, the parallel development, which is related to virtual reality, but separate or more advanced, is augmented reality. And this may be a new concept, so I would... Yeah, that's the problem with VR. I had stronger language on the slide, but I decided to be nice. Yeah, so this is our future, and it's maybe okay for this guy, but you know, save the children. So this thing you can look up maybe from the slides when they are posted. Too much to go into detail, but some have even posited that the Fermi paradox, if you're familiar with that, namely, if aliens out there, why haven't we heard from them, could be due to civilizations withdrawing from the real universe to much more pleasant heavens of their own creation. I won't dwell on that. So the inspiration for the project is from Cyberpunk games, and maybe Cyberpunk is familiar, maybe not. It would be things like exactly Johnny Mnemonic and Neuromancer, started in the 80s, maybe typified by things like The Matrix as well. So games maybe some of you have played, and this is what they look like. They're quite immersive these days, quite beautiful even. This is a fairly new game. Basically what we want to do with this project is make this real. So not behind the screen, out of the screen. And there's of course already for a long time people have been playing so-called live action games. There's a few examples. Don't know how popular they are over here, but maybe anybody play Airsoft? A few, we'll admit anyway. And paintball is very similar, laser tag for kids mostly, and then we have, of course, lately rudimentary augmented reality games like Ingress, Pokemon Go, fads. So this is what a typical high-end Airsoft game looks like. This is not actually war, this is a game, a real game in the real world, and these people are very serious about their games, as you can see. But you know, I say good for them, at least they're not sitting in front of a computer. So this is what we want to do. That, just add drones. Humbly. And the other way to describe it might be, let's say, Terminator as a scenario, as a game scenario, would be rather fun, right? That we want to have a shooting game between, well, of course, humans and humans, that's baseline, that's Airsoft, but humans and machines, machines and humans, and also mixed teams. It's a project that will take a few years to fully realize, but we are building it. And let me show you a nice little demo example, not our work, but shall we say congruent of how something like this might look like. There are, of course, other people doing the same. Yeah. So this is all manual control, of course. Somebody is controlling the drone. I think you get the idea. So, not sure what exactly happened there at the end. Maybe the drone was shot down. That would be fantastic. So that's pretty much the idea. And the idea, though, is that we do not want the drones to be manually controlled. Rather, they should be automated. And the other component of this is the man-machine interface, which is why I'm talking about augmented reality. Let's see, I'm going to skip that one, but here's a depiction of our future as well. So you all know Google Glass. That didn't happen, but these devices are coming out. Actually, this year there's a number of them on sale. And our future might look something like this, generally speaking. The smartphone might not be the only way of interacting with our computers. This, of course, could be considered dystopia. And I think you get the idea. And there's another clip here. If you're interested, you can look. There was a TED talk this February by the founder of a company called Meta, who now have this headset out on sale, and it's pretty cool. So these headsets are coming out. They are. You probably have heard about Microsoft's HoloLens. The price point is about 3,000 currently, but they are now shipping, and they're pretty amazing. And it's a matter of time before this all gets miniaturized, and perhaps someday, a few years from now, a bunch of you would be wearing this in the audience, and it wouldn't raise much of an eyebrow. But yeah, you can look this up if interested. So here's a quick explanation of the name. So there's this levels of reality. You know, physical reality. You can't win. You can't break even. You can't even get out of the game. You know, it's the game we're all stuck in permanently until the end, and there are no reboots, no retries. And then we have social reality, which a lot of people perhaps don't distinguish from physical reality, but actually are just the norms of the tribe, the laws and whatnot. In the terms of Morpheus from the Matrix, it's the world that has been pulled over your eyes. And then we have what might be called consensus reality. This would be, currently an example would be something like Wikipedia or Google Maps. We all agree on this certain, well, we don't actually all agree on these certain facts about the world, but you go to Wikipedia and often it's good enough. You might have any number of critiques, but it's good enough. Now what's going to start happening with augmented reality is that consensus reality becomes much more important, because all of these overlays on the world that the video demonstrate and that are going to happen, they're basically just extensions of current Wikipedia, Google Maps, projected into 3D space. And so this is maybe an explanation of the name. We want to create a platform that enables that for more fun than just navigating around the city. And another way to put this project into context, we are creating tactical software. This is an open source category that is missing. So for the last 2 decades, since Apache, Linux, PHP, all of these things, we have almost everything as open source, even really boring stuff like accounting software. Everything exists that you could ever want, except what we don't have is anything that could be called tactical software. And what's tactical software? Well, what would you need to implement a game like this, or rather a game platform? We are not creating a single game, more the platform for let 1,000 games bloom. Well, you would need a whole lot of things. Some exist. Open source autopilots, quadcopters have popularized them and driven the development. We also use ArduPilot, makes sense. It's 200,000 lines of code, no need to write it from scratch. Some physics engines exist, especially in games. Problem is they don't actually have any veracity. They don't really simulate real physics. They take liberties because it looks a lot better in games when you tweak the constant g, the gravitational constant. It's more immersive and accelerated and in your face. What doesn't exist exactly is then things where we could have the drones accurately aim their weapons, which is why the video I saw earlier was all manual control. So this is one sub-project of our project, what we are creating. And what doesn't exist, generally speaking, things like laser guidance, motion prediction, other things we need to make this happen. So you can see why it's a few-year project. And it's also a great learning project, and this is getting to the recruiting part. If you know what a whole lot of these acronyms mean, or these technologies, what they are, I'd probably like to talk to you. I don't know if you'd like to talk to me, but if you do, you can find me after. So it's just an insane amount of technologies that I've had to learn over the last year or two in preparing the ground for this project, and there's no end to the list. So just to wrap up, these are some of our current prototypes. They're very, very primitive as yet, but we have moved from buying commercial drones to building our own. And so now we have a 3D printer, We're beginning to build our own concepts and going to do some mechanical engineering, electrical engineering to build our own circuit boards, starting from the BeagleBone and the Raspberry that we have been using so far. And maybe in a future talk I can actually, if the logistics work out and if they let me through the border, I might be able to bring some of these concepts with me. Yeah, so that's pretty much it. We have currently a team of 6 people. Not everybody is working with Elixir and Nerves, but everybody is learning them. And we're pretty much based in Berlin, Bratislava. We do hackathons. Sometimes they devolve into drinkathons. There was actually a single 2-day hackathon, and those are all wine bottles. This project actually made me give up alcohol. So I'm sober now 3 months and 20 odd days since New Year's. And but hey, indulge. And this is what our typical hacking environment looks like in Bratislava, overseen by our god, Charlie. The next hackathon will be in Berlin the first week of April. So actually, basically next week. And if you're interested to attend, talk to me after. And so, recruiting. This is, nobody's getting paid. This is totally non-commercial at the moment. It's all public domain, by the way. So it's no copyright, all copyright disclaimed. Anybody is free to do anything they want with all the code we produce. And we want to keep it that way. However, I think that if you were looking for a challenging, fun project to contribute to, it's hard to find a more difficult problem. This is definitely highly challenging. And hence, plain old fun for those of us who like challenges. And it's going to take a few years. So talk to me after if you have any interest. And that's pretty much it. Any questions that you dare to pose publicly?
Why does Roma stand here?
It's just a prop. It's too dangerous to fly inside. So with these propellers, you would seriously hurt your fingers. So we will fly it outside in a moment, but it's just there to make this visceral. I don't like VR, I like reality. Anyone else?
Nervous about API to hardwire, or what's the advantage?
Can you repeat, please?
This nervous
Yeah.
framework, what's the advantage? As I can see from the code you showed us, it's just API to the hardwire.
In this example, yes. This wasn't the greatest code example, for sure. Nerves is more not just a library, so this was an example of the library. It's the tooling. So it's the tooling to do all the heavy lifting. If you start with embedded yourself, you would have to figure out cross-compilation from what's most likely your x86 laptop to ARM as the target device. And cross-compilation is, nobody likes it, rightly so. So the Nerves project has figured out all of that, and not just for C, C++. We have a high-level language we can use, and actually you can use others. We use a little bit of Python as well in our project because some libraries are not in Elixir yet. So it's mostly about the tooling, not so much the libraries. That library I was using for those Chrome modules. It's actually one I wrote and open sourced, and it's not that important. It was just a bad example, perhaps. And you had a question.
Are you not afraid that your project with reality and games will be used as guns in the wars for killing people, something like this?
The answer I would say is twofold. One is that technology is value neutral. Technology is value neutral. It's up to the people who use them, whether use it for good or evil. And the second thing is that most of that kind of killing is being done by governments, and they have all this stuff already. They don't need our little project. So yeah, but of course there could be a longer discussion to be had on that. But maybe after event, over over some drinks.
3 months.
Anybody else?